Welcome to the Crazy Hat Chemist, so another video here in acids, bases, and titrations. Okay, alright, so let's get moving. Bam! So today we are talking about buffer calculation number 2. Okay, what is the pH of a buffer solution composed of 0.700 molar acetic acid with 0.600 molar sodium acetate? The Ka for acetic acid is 1.8 times 10 to the negative 5. Now, this should look very familiar to you because I'm hoping that you remember buffer calculation number 1 in this same unit where we used an ice table. Okay, this is exactly the same problem, but we will be solving it using the Henderson-Hasselbalch equation that we just derived and not an ice table. That is the beautiful thing. Okay, so this is the Henderson-Hasselbalch equation, which is the pH is equal to the pKa plus the log of the conjugate base over the conjugate acid. So let's look at this problem and figure out what parts we actually have. So we most certainly do have the Ka. We can plug that in here, take the negative log of that, and get the pKa. All right, and then we also have the conjugate base. That is, sodium acetate is a strong sodium acetate is a salt. So the sodium ion, don't have to worry about that because that's a conjugate to a strong. And then we have the acetate ion, which is the conjugate of the acid here in this problem. Then we have the acetic acid, which is the acid here. And we can plug that in. So we're going to plug in all these values into that Henderson-Hasselbalch equation and not use the ice table like we did on the previous problem. So I've plugged in these values. I got pH is equal to the negative log of 1.8 times 10 to the negative 5. That's the Ka. Plus the log of 0.600 divided by 0.700. I'm going to simplify this equation here just a little bit with that division problem in the log. And then I'm going to add these two numbers up. And you should notice something here. And I mentioned this in the derivation of the Henderson-Hasselbalch equation. But the pH of buffers is largely dependent upon the pKa of that acid or base in this acid in this case. Okay, because that addition problem of the log of the conjugate pairs is very, very small in comparison to the pKa. So here's our value. The pH is equal to 4.68, again 2 decimal places. And you should compare this. This is exactly the same answer that we derived in the buffer calculation number 1. Make sure that you check that out. Okay? Again, I am the Crazy Hat Chemist, and of course we can't end these videos without a crazy hat. And a little merchandise plug here. Don't forget about getting a sticker and of course a crazy t-shirt with, ooh, look at that on the back. Give me a thumbs up if you like that video. Subscribe to my YouTube channel. I'm going to see you next time for more cool chemistry videos and acids, bases, and titrations, and oh, so much more. Talk to you later. Bye now.